Ever wonder how ChatGPT got so good at conversation? Turns out there's a secret reinforcement learning algorithm behind the scene, optimizing its dialogue skills. Proximal Policy Optimization, or PPO for short, is the secret sauce giving ChatGPT its uncanny human-like chat abilities. In this video, we'll demystify PPO and unpack how it helped catapult ChatGPT to stardom, seemingly overnight. PPO, or Proximal Policy Optimization, is the secret recipe that makes ChatGPT smarter and more engaging as it grows. Think of it as ChatGPT's personal coach. This algorithm goes beyond the usual chatbot chatter by fine-tuning its responses in real time, adapting to your style, and making every conversation feel like a tailor-made experience. In this video, we'll peel back the layers and reveal how PPO works its magic, creating a dynamic and responsive chat companion. Understanding reinforcement learning. To really comprehend reinforcement learning, it helps to think about how we as humans learn. When we were young, our parents would praise us when we did something good and scold us when we misbehaved. Over time, we learned what types of behaviors were considered good versus bad based on this feedback. Reinforcement learning agents are modeled after this idea. They explore different actions within their environment, receiving feedback on which actions are favorable based on the resulting rewards or penalties. The agent then develops a strategy called a policy for deciding which actions to take in different situations in order to maximize its cumulative reward. An RL agent's policy determines how it behaves at any given time. The goal of reinforcement learning is to learn the optimal policy that yields that highest possible reward over the agent's lifetime. This often involves a healthy dose of exploration, mixed with exploiting actions that are known to produce rewards. Mastering this balance is key to effective reinforcement learning. A challenge with some reinforcement learning algorithms is instability during training. Making excessively large changes to the agent's policy can cause wild fluctuations in behavior. This slows down learning and causes the agent to struggle. Proximal Policy Optimization, or PPO, aims to address this problem by constraining policy updates to relatively small increments. PPO accomplishes this by using a nifty trick known as clipping. In a nutshell, clipping limits how much the new policy is allowed to diverge from the old policy at each update. You can think of PPO as a governor, preventing the agent from veering too far off course during training. These controlled policy tweaks enable stable, efficient learning without dramatic shifts in the agent's behavior. While the updates are smaller in magnitude, PPO consistently outperforms earlier algorithms designed with stability in mind. How PPO works. To fully appreciate how PPO pulls off more stable reinforcement learning, we need to take a quick dive into some of the math powering this algorithm. The key ingredient is the PPO objective function. This function defines the goal of the optimization process, which is to maximize cumulative reward through automatic adjustments to the policy. The PPO objective function examines the ratio between the new policy and old policy. When the agent takes an action under the new policy that results in higher reward, PPO increases this ratio to make that action more likely moving forward. On the flip side, actions producing lower rewards cause the ratio to decrease, thereby discouraging those actions in the future. This is where clipping comes into play. PPO clips the policy ratio, meaning it limits how much the ratio can change from its previous value after each update. This clipping threshold is usually set somewhere between 0.1 and 0.2. Effectively, this controls the pace at which the agent's policy evolves. Clipping prevents wild swings in the policy by keeping changes relatively small. We could think of it as a safety harness, keeping the agent from straying too far off course during training. This stable learning is what enables PPO to achieve excellent performance across many different environments. PPO in ChatGPT. PPO played an instrumental role in training ChatGPT. The key challenge was enabling ChatGPT to carry out natural-sounding conversations spanning many topics. Reinforcement learning with PPO was used to provide feedback during training based on how well ChatGPT's responses matched what a human would say. Responses that were accurate and contextually relevant were rewarded, while irrelevant or incorrect responses were penalized. For example, if we ask it a question about Paris, ChatGPT needs to know Paris is the capital of France and provide an appropriate response. PPO helps by rewarding this model for correct, on-topic answers during training. Over many training conversations, ChatGPT progressively improved under PPO's guidance. The algorithm gently nudged this model towards more human-like behavior through slight policy tweaks, rather than dramatic overhauls. Thanks to PPO's stable training approach, ChatGPT learned to produce remarkably human-like dialogue, covering an astounding range of everyday conversation topics. The end result is an AI system that quite convincingly mimics human interaction. Benefits of PPO. There are several key reasons why PPO has become a preferred reinforcement learning algorithm. Firstly, the constrained policy updates generally promote stable, reliable learning compared to prior on-policy algorithms. This avoids unwanted fluctuations during training. Additionally, PPO is model-free, meaning it can be applied flexibly across many different environments and problems. This versatility makes PPO a great all-purpose RL algorithm. Finally, PPO is quite simple to implement and tune relative to other reinforcement learning methods. It does not require explicitly remodeling environment dynamics or maintaining auxiliary value functions. Taken together, these advantages explain PPO's widespread adoption for cutting-edge applications like training ChatGPT. For both simplicity and performance, PPO hits a real sweet spot. Alright, that wraps up this overview explaining proximal policy optimization and how it enabled more effective training of ChatGPT. We covered the basics of reinforcement learning, how PPO stabilizes training through clipped policy updates, and why this algorithm has become so popular. I hope you enjoyed this introduction to PPO. Let us know in the comments if you want me to explore any other neat reinforcement learning algorithms in future videos. Thank you for watching.